Today we start the simplification of CFG as we have already taught in the previous lectures that how to eliminate the useless symbols from the context-free grammar. Then today we want to study the second point, the elimination of unit production. How to remove the unit production from the context-free grammar. Now the second point, if you want to eliminate the elimination of second point, elimination of elimination of unit production. Unit production. If there is a unit production in the grammar, then how to reduce that unit production in the specific grammar for the useful grammar. There will be some example which you want to discuss that how to remove the unit production in this grammar. Suppose the example is like this: S tends to AB, A tends to small a, B tends to C, capital C oblique B, capital C tends to capital D tends to capital E, and capital E tends to small a. If this is the grammar, then in this grammar we have seen here that there is unit production. The unit production is here. B tends to C, B tends to C, and again there is a unit production here. C tends to D, and there is again unit production here. D tends to E. Then this is a continuous unit production. And how to remove this unit production in CFG? Then we already taught you the how to remove the user symbol. Then today we study the how to remove the unit production from the context-free grammar. Let us start how to remove the unit production. Okay, take an example. Now the algorithm proof. Let a grammar of language L of form G is equals to Vn T P and S. Then we can construct a grammar G dash is equals to Vn dash T P dash S. Then let us start. Suppose there will be a string xi. Suppose x1 that x1 maybe belongs to a value a, that a that is equal to starting symbol s, that start from s. Then we can calculate the value of the x1 xi plus 1 of a is equal to xi a union b is the element of Vn such that C tends to B is in production is in production with C is the element of xi of A. This is the methods how to calculate the value of unit production with this formula. If you apply this formula, then you can get the exact result how to remove the unit production with the, on the CFG. Now, if you are taking the example, previous example, which you already have written here, this is the example. S tends to AB, A tends to small a, B tends to C, C tends to D, D tends to E, and E tends to A. Let's start how to solve it. Example solution. Now we can just calculate first the x0s, that is equal to S, static symbol of the grammar. The s can produce AB, then the value of S equal to S. There is the value of x1 of S, that is equal to value of x1 of S. According to these theorems, xia means S, and the union of B is the element of Vn, such that C derives B is in production with C is the element of xi, but there is no any unit production for S. S has AB, there is not any production of S, then S cannot be again further unionize anything, and that is only S. Then the value of S is the value of xs is equal to S. There is no any further extension of S. But if we go to the further next value of xi, then the value of xi x1 of A, then if you check the value of x1 of A, then the value of x1 of A maybe rise A tends to small a, there is only A, there is no further value of A again, then that will equal to small a. Similarly, value of E, again value of x of E is similarly E. There is no any unit production in this value. Again we can come to the B, variable B, then we can check the variable B. Then if we check the variable B, then x1 B, then first is equal to x1 B is equal to B. Then if you calculate the x2 B, then the value of x2 B is equal to B union B tends to C. B tends to C is unit production, then that is equal to C. Again if we calculate the value of x3, that is again means B, and that is again x3 of B, that is equal to BC union, that is again C can again derive D, that is equal to D, and D is the variable, D is in the variable. Again you can calculate the value of x4 of B, then the value of x4 of B means B C D union, there again D can derive E, there is a E, then the further x5 of B, there is only B C D and E. There is no further more description, there is only the B can derive C can derive D, and D can derive E. The value of B has four components, 4 unit production. Similarly we can derive C x1 C. Value of x1 C is equal to first is C, then value of x2 C, that is equal to C union D, the value of again x3 C, that is again C D union E. Then the value of x4 C is equal to C D and E. That is the final value of xc. Then further we cannot go further division. Similarly, the value of D, we can calculate the value of D. Then x1 D is equal to D first production. Then the value of x2 D, that is equal to value of D union value of E, because D can derive E, then we can write here. Then value of x3 D, that is equal to D E. Then there is a final value of every variables, that is the value of means x of s is equal to s, that is the final value s, and x of a, that is final value of a, and that is x of e, that is final value of e. And similarly that is only the unit, and that is the multiple production, and that is the unit production. X1 x of b, the x of b is equal to b c d and e. Similarly, value of c is equal to c d e, and the value of d is equal to d and e. These are the unit production. Then how to write the grammar for this according to the final result? We can put the same value of the same which you are getting. You can put the same value which have get the terminal symbol. Then if you write the correct grammar for this, then the correct grammar for this is like this. For the example, we can write again an example here. S tends to AB, A tends to small a, B tends to C oblique B, C tends to capital D, E tends to small a. This is the grammar. Then can write the exact form of the grammar like this. That is equivalent. S tends to AB. As I know any unit production, then S tends to AB is in the right form. That is right equation, right form. A tends to A, that is the same as. Then B tends to C, and C tends to D and D tends to E. D tends to E, and E tends to A. That is a grammar which are in the which are given in the example. Then B tends to C, C tends to D, D tends to E, and E tends to A. It means we can write here directly B tends to C. The value of C, you can replace the value of C with the help of A, then A oblique B. Similarly, the value of C we can replace with the help of value A, because A can replace with the help of A, and the value of D we can replace with the help of A, and value of E we can replace with the help of A. Then this is the final outcomes of the unit production. Then first rule, applying the first rule, remove the useless symbol. Then the grammar we are getting here, that is the start from the reachable state, reachable symbol s. Then s we can derive ab. Then the final grammar is s tends to ab, a tends to small a, or b tends to a oblique b. C cannot traverse from starting S, then we can not get this production in the results. And again we cannot reach in the D, and we cannot in the E. Then all these symbols are discarded. Then finally we are getting the conclude grammar, that is called your final grammar. Then in these methods we can get the results, exact results which you want for the final results. Now this is the methods that how to reduce the unit production in the context free grammar. Now the third point elimination of null production. How to eliminate the null production in the grammar? If there will be null production on the right hand side of the grammar, then if you want to remove this type of symbol, useless symbol, this type of symbols in the grammar, then how to make the suitable justify grammar which are useful for the derivation of language. Now suppose an example, and there will be example s tends to a s oblique ab, a tends to epsilon, b tends to epsilon, and d tends to b. Suppose this is the grammar, and that grammar symbol there is a more epsilons, means more null variables. A tends to epsilon, b tends to epsilon. Then how to remove that epsilon? Because that can get the big role, because if we can replace this a with the help of this production and this b with the help of this production, then the value of as may be effective everywhere. Now we are applying again the uh, new algorithms how to reduce the null production in the context free grammar. Now suppose we are taking the example, and again we want to do some some algorithms. Now proof, let there be grammar G uh, which define the language L in the form of Vn, T, P, and S, and we want to construct the grammar G dash, and that G dash is equals to Vn dash, T, P dash, and S. This grammar we want to construct from the reduced grammar, from the given grammar. Then what steps we are doing? Step one. Suppose x1 is equals to a1 is the element of Vn such that a1 tends to epsilon is a production is a production in G. Suppose this is the first case that some variable generate the absolute production. Then how to reduce that production with the another production? Then the value of x I plus 1 is equals to value of xi union a1 is the element of Vn such that there exists a production with alpha tends to sorry with a tends to alpha, and alpha is belongs to wi star. This is the case if xi is the value which come from the first, they can drive the null variable null values that variables, and which can derive that variables from the grammar. They can add it with the xi. Then take an example from the previous this example. We have checked that how to calculate the value of x. Now here, according to this rule, the value of x1, that is equal to all the values which produce the null symbol. The values which produce null symbol a and b. A and b is the grammar. Then a is the element and b is the element which produce the null value. The value of x1 is equal to ab, which produce the null value. Now the value of xi plus 1 can be calculated with the help of this. Then the value of x2 is equals to value of a b union the value which can derive this. And it means a and b, which is the symbol which can drive this these variables. These variables can drive with the help of s. Then we can add as a s in the table of this. Then the value of x2 is equal to a, b, and s. These are the variables which are affected from the rules of elimination of null productions. If you eliminate that symbol, then what is the impact of the grammar that we can write here? We can replace that symbol with the help of one by one, or you can help up with the help of same at a time. Then the first alphabets we have seen the first s tends to as. There is no change. As it is. There is a. Then a can replace the help of null. Then the value of a is nothing. There is null. Then that may be a and b. That may be a, or that may be b, or the value of a is null, b is null. Then we can say the value of a is null and b is null. Then in that case, the value of this is equal to a, is equal to null. Here we can replace a is equal to null and b is equal to epsilon. But when we get the final results, then if we remove a is equal to epsilon and b is equal to epsilon, these can be removed from here. Then we can remove we can put the value of s in that case. Then s tends to, that may be a s oblique a. That is the final result of the grammar which you can extract from the result of this grammar. Then this is the methods how to reduce the null production from the grammar, and then we can get the final results.